Okay, so now let's talk about section 2.4, the one-sided limit. This section is going to be a very brief session, as we talked about what is the definition of limit, how do we evaluate the limit, right? So we talked about a lot from 2.2. And so let's talk about the one-sided limit, okay? Um, you think about it, guys, when we're talking about this definition of limit, let's say as x approaches 1, we will consider two directions, right? Limit as x approaches 1 from the left side, and also limit as x approaches 1 from the right side. Okay, so this is a brief idea of the one-sided limit. So let's look at one example here. Given f(x) is this function equals x over square root of x, okay? And we know that for the domain of this function is x cannot be 0, okay? And as you can think about it, guys, the bottom is the absolute value sign here. When x is greater than 0, then the absolute value of a positive number, which is the number itself. So a number over itself, which gives us is 1. However, when x is less than 0, then the absolute value of a negative number, it can become a positive number, okay? So a negative number over the negative of the negative number, which is a positive, so you're gonna see that it's negative 1, okay? And as you can tell, guys, for here, you see, if we let x approaches 0 from the right hand side, which I'm going to trace the curve of this function from the right hand side. As you can see that, let me label this. This is 1, this is negative 1 here, okay? As x approaches 0 from the right, you will see that the right side limit, it equals 1, okay? However, as x approaches 0 from the left side, you will see that that left side limit actually equals negative 1. So the idea is very, very, very simple, okay? And this is the notation. Limit as x approaches 0 from the right, we write as 0 on the upper right, there's a plus sign. As you can see, guys, when you write a plus, or you can see that it's my x is always greater than 0, okay? You can also think about this as the positive sign, okay? So a number starting from the positive side of 0, which is from the right, and then let it getting approaches to 0. And the corresponding it equals 1, okay? So this is called the right hand limit, okay? Correspondingly, the left hand limit, the way is limit as x approaches 0 from the left. As you can see, it's a 0 on the upper right. There is a negative sign. That means, okay, this one side limit, I'm starting from the left side of 0, meaning it's the number, it's all smaller than 0, right? Which is from the left. And then we can see that it equals to negative 1. Okay. As you can tell, guys, the right hand side limit and left hand side limit, they are different. One is 1, the other is negative 1. Then you will see that limit as x approaches 0, f of x, it does not exist. Why? Because the left side limit does not agree the right side limit. Okay, so yeah, we're gonna give you a theorem right now. Okay, so the theorem, let's look at the theorem here. It says like this. Limit as x approaches c. C is the approaching number. F of x equals capital L. This, you see the two arrows, right? If and only if the right side, the left side limit equals the right side limit equals capital L. What does that mean? That means if you claim limit as x approaches a number c, f of x exists and it equals capital L, you can definitely get to the conclusion the left side limit exists equals capital L, and meanwhile the right side limit also exists equals capital L. Okay, same direction, same thing. If you get your left side limit equals right side limit equals capital L, you can definitely give the conclusion limit as x approaches 0 f of x equals capital L. Okay, so fairly strong theorem. Okay, if and only if. Okay, and also let's maybe look at one more example about the one side limit. This again, so this is a very standard problem here. So let's take a look at here. F of x equals square root of 4 minus x squared. Okay, and believe it or not, the domain for this function actually is negative 2 to 2. Okay, and if we plot this function on our xy plane, and you will see that actually this is a half circle. Okay, this is a half circle because think about it this case. If we replace fx with y, so we have y equals square root of 4 minus x squared. You know, if you simplify, if you square on both, you're gonna have y squared equals 4 minus x squared, and then y squared plus x squared equals 4. So this actually stands for a circle centered at 0, 0 with radius 2, right? But you see, guys, we get this equation, but also put the restriction our y is greater or equal than 0. Why? Because I have a positive radical, right, square root here, so it's just the upper part of the circle. So anyway, let's look at this two questions here. So limit as x approaches 2 from the left, f of x, what that limit equals to. As we can see from the graph, this is our domain from negative 2 to 2, and the left side limit for 2 actually, do you see it equals 0, which is here, right? And similarly, limit as x approaches negative 2 from the right, which is you are approaching from this way, so the corresponding limit, right side limit for negative 2, it also equals 0. Okay, and of course, guys, you can tell there is no right side limit for 2, and there is no left side limit for negative 2, right? Because it's not even defined outside from negative 2 to 2. Okay, and last, there is a theorem here. For here, I want you to know this theorem, and there is a proof in our textbook in 2.4, and the proof, it is good, but it's kind of long and tedious. What I can guarantee you is in chapter 4, in the middle of chapter 4, we're going to learn one type of method to handle this type of limited questions, which is called the L'Hopital rule, you know. And you see this limit, theta approaches 0, sine of theta over theta. If we plot theta equals 0 into the top and bottom, you're going to see that sine 0 is 0, theta is 0. So you're going to have 0 over 0 form. This is what we call the indeterminate format, okay? And again, maybe spend 2 seconds, or I don't know, maybe 20 seconds to take a look at this, and then to have a brief idea. This limit equals 1. But why is equals 1? Well, wait for the middle of chapter 4, and we're going to talk about the L'Hopital rule. This is a one-line deal. Okay, so this is the basic things for section 2.4, the one-side limit. It's very straightforward, and I'll stop here. I'll see you soon. Okay.